Hello everyone, I am Surendra Jain, Master Teacher of Mathematics in Vedantu. I have brought a series for ISI and CMI preparation. In fact, these sessions are very useful for JEE Advanced also. As continuation of my previous session in which I discussed a solution of 2019 UGA of ISI, today I will be discussing UGB. UGA was having 30 single correct questions, whereas UGB is having 8 subjective questions. Difficulty level of UGA is easy to moderate, you can say, but here in UGB you will be finding questions to be little difficult on as compared to UGA. So this is first question. Let us see what this is. Prove that the positive integer n that cannot be written as sum of r consecutive positive integers with r greater than 1 are of the form n is equal to 2 power l for some l greater than or equal to 0. Now to prove that, I will be proving two things. First is that suppose I am having r consecutive integers. Let us say my first integer is a, my second integer is a plus 1, and so on. And then we are getting a plus r minus 1, that is the last rth integer. So by using sum of n terms of AP, it will be r by 2 because total number of terms are r into first term plus last term. So it will be 2a plus r minus 1. So first I will prove that it cannot be equal to 2 power l for any integer l or for any positive integer l. In fact, in this question, they should have given L to be positive integer, then it would make better sense. Okay, so suppose, and to prove this, that it cannot be equal to 2 power L, I will take this to be equal to 2 power L. And by contradiction, I will be saying it is not possible. Dear all, please see, if this is 2 power L, then R cannot be odd integer. Because if odd, then 2 power L doesn't have any factor that can be odd. So this R has to be even. And if r is even, then 2a plus r minus 1 will be odd because 2a is odd, a is integer, r is even, so 2a plus r is even, minus 1 will be odd. Okay, and if that is so, then this product will have some odd factor into it. So this cannot be equal to 2 power L. I hope you are getting it. So we have got a contradiction. So this sum of any r consecutive integers cannot be equal to 2 power L. Now dear all, please listen carefully. This much should not be sufficient to conclude this question. Why I am saying so? Now what we have proved, that any number that can be written as sum of r consecutive integers cannot be 2 power L. Now what if there is an integer that cannot be written as sum of r positive integers? Can it be 2 power L, or can it also be in some case not equal to 2 power L? Okay, because here we have only proved that sum of r consecutive integers cannot be 2 power L, but the other case of this, how we can say that it will be 2 power L only? To say that, what we should do, we should prove the converse also. Like if I take some number n to be 2 power L, or rather not 2 power L, and then I will prove that n can be written as sum of r integers, r consecutive positive integers, r consecutive positive integer. Let us see how that we can do. Let me do it on the next slide. So suppose my n is not equal to 2 power L. So one of the case could be that my n is some odd number. Okay, case 1, that n could be odd number, and I think odd number we can take as 2m plus 1, and we know 2m plus 1 means we can write this as m plus 1. So this is sum of two consecutive integers are greater than 1. So this is true that if n is not 2 power L, and for this case is that n is odd, then I think we are done, that it can be written as sum of two consecutive integers. Now suppose this n is not odd, but n is some 2 power, let us say p, into some odd integer. Okay, I think this will cover all the even integers except those which are of the form 2 power L. Okay, and when I'm saying odd, it should be greater than 1. So this will be 2 power p into 2 cube plus 1. I am taking this. Okay, now this number, to show you that how this can be sum of r consecutive integers, please see what I'm going to do. I will write an AP whose middle term is 2 power p. Okay, and then I will add a term which is one more than this 2 power p, and then I will add one term that is one lesser than 2 power p. And similarly I will add here 2 power p plus 2, one more I have added here, and here I will be subtracting and it will become 2 power p minus 2. And this way if I keep on doing, you can see, okay, I have added q terms here and I have added q terms here, and by use of sum of 2q plus 1 terms of AP, or property that sum of first term plus last term is equal to second plus second last term, and so on, I think you can check this sum will be equal to this thing. Okay, now to give you an example, let us take 14. Let us take 14. 14 is 2 power 1 into 7. 7 is odd number. If I do the same thing to this, what you can see, I can write 2 here, 3 here, 4 here, 5 here. So 3 numbers I have written here, and I am writing 1, 0 and minus 1 here. Now, there is one very interesting thing here why I have taken this example, that if you take this thing, you can see it is definitely sum is equal to 14, but it is not consecutive positive integer. You can check this minus 1 plus 1 0, 2 plus 3 5 plus 5 10 plus 4 14. So in this case what we can do, we can ignore these three terms in the beginning, and we can say 14 is the sum of these four consecutive positive integers. And this kind of situation, whenever it will come, okay, we can ignore that many of terms so that negative terms are, negative terms are ignored. For example, here suppose I was taking 2 power p minus q, my this term would have been, I think, 2 power p minus 2, yeah, that's correct. And the next term would have been 2 power p minus q plus 1. Okay, now suppose this is negative, okay, then this will be 1 more than this. Then similarly 2 power p minus q plus 2, that will be 1 more than this, and so on. Okay, so at some point of time you will get 0 also. Then you will be having terms which will be 1 more than this 0, and then next term, then next term, and definitely 2 power p is positive. So ultimately after some time these terms will be only positive. But you can definitely count these number of terms in which sum will be 0, and you can say this number 2 power p into odd can be written as sum of r consecutive positive integers, where my first integer starts after this term. After this term means the sum where it was 0, so we can start from here. So this is how we can say that any number that is not of the form 2 power l can be written as sum of r positive integers. A number that is of the form that can be written as sum of r consecutive positive integer, that cannot be 2 power l. So I think we have proved any number that is not 2 power l if and only if it can be written as sum of r consecutive positive integers. So I think we can say that very safely that n, if not sum of r consecutive integers, has to be 2 raised to the power n. So this completes the solution of this question. Okay.